Sorry if I broke your eardrums, but the sound seems to be working. Good. Uh, as they say, third time's the charm. This is third time I'm recording this because I kept finding bugs. For the AI course, I built a behavior tree AI. For the teacher, I kind of said that I would be building the behavior tree from ground up at the beginning. Well, that didn't end up happening. I ended up using a pre-built asset. I ended up using this pre-built asset for the behavior tree. AskBlue Fluid Behavior Tree from GitHub. I will link this to the description of the video. But this has all the nodes and everything required. The idea of building customizable visual behavior tree on top of Unity just didn't turn out to be feasible within the time frame I gave to myself or we had for this course. AI agents themselves, they are the blue dots here, the capsules. As you can see, they have a field of vision. They have obstructions. If they see the player, they go to player. I can move the player away. They will continue patrolling. They will go to where the player was last seen. So if they reach the target, currently it just logs that hey, we reached the target. I was supposed to make it so that it actually reset the game, so you'd have to fail, and your goal is to come here. The way the game works itself is that you turn the area, and obviously I have rotations currently turned off because for testing purposes of the AI. But yeah, you can rotate the area as you wish. Rotate the ball around the area as you wish. There is a bug with the ball that it quite often decides that hey, I'm gonna actually go under the map for no reason and have fun. But I fixed it just by having the ball come back up whenever the ball reaches below X value, it comes back up and now it's out of the map. Yeah, this is a buggy mess still, but the main purpose was the AI, so I don't care. Yeah. If we go back to an AI agent, let's say this one for example, it has a field of vision that can be adjusted to be as much as I wish. I set up it to be 20. The field of vision angle can be adjusted. Now it cannot see. Now it can see all around itself, except basically in a 1 pixel line on the very back. Adjusted. The AI always knows, or the player reference is basically just, hey, I know what I'm looking for. The field of vision in its own script. It has an obstruction layer, so if you take any of these agents, it wants to really go there right now, but it cannot see the player through the walls. However, it can see player otherwise. Now it cannot see the player. It works with layer masks, so the player has target layer mask, all the walls have an obstruction layer mask, so it cannot see them. This is a bug with the AI. I don't know why it works like that, but sometimes it just gets stuck on the repeat until success loop. But if we take any of the other AIs, let's see, we take this one, you can see it keeps patrolling around, it keeps on this loop. If we take this guy, it breaks. Cool. This guy works as it's supposed to, so whenever it sees the player, let's lock this guy in. You can see the right. So whenever it sees the player, it goes to where player is, or it's supposed to go. And then it's supposed to keep patrolling. Yeah, something broke. Anyway, let's get to the actual meat and potatoes of this project. So the code side. The code works with the, like I said, the fluid behavior tree system. and this is basically the entire thing here. Let's zoom in a little bit so we can see better. So what it's charged with, we build a behavior tree and awaken. First selector node is basically, do we see the player? Okay, we don't see a player. Let's go to a random position within the distance we have selected and check again, do we see the player? If we can see the player, we set the target current position to be the target transform position, so the current target's position, current position of the target, and we set the destination to target position. That should be target current position though. That is, yeah. Yeah, target, we set the agent to go to target's current position. Then we return successfully. So now it goes to the current position of the target. Then we check if the distance between the target's current position and the agent's current position is less than 5. I wanted this to be 1, but it caused the bug where it never reached the 1, and well, this one would reach 1, but this one wouldn't reach 1, and obviously if we are checking the target's agent's current position and the target's actual current position and not the position we logged for the where the player AI to go, it cannot be less than this actual position, so I had to set it to 5, so it shouldn't cause too many issues. It's supposed to run a capture the player loop, but since the capture the player doesn't really do anything, it only sets a 1 boolean value to false. I have currently just set it out of the way so it doesn't break anything. So this part of the AI will never actually run, but this is just supposed to reset the AI anyway. Then, yeah, if it returns successful in either of these, this repeat until success node is successful, and we go to just resetting the path, and we flip back here, doing everything again and again. AI, the patrol tree basically runs on this. This is how we take the can we see the player, so boolean value, and it comes from AI World of Vision, which we can open up as well, but let's first explain the rest of this thing. This is how we pick the random point. This is not my code, this was taken from YouTube mostly, or from YouTube, but mostly it is from straight up just samples from Unity itself. What it basically does is takes a random point within a range around us, and the range around us is determined by this variable, which due to, let's take somewhere where it's straight up the same, which because of the AI World of Vision script we can also see the range around us, but this couldn't be normally here with this script. It takes a random point within that range, and if it is inside nav mesh, it goes there. If it is not inside the nav mesh, it takes the closest result to the nav mesh within the nav mesh and goes there instead. And player position check, this is sorry. This is kind of how my AI is cheating, so it always knows where the player is instead of taking it from this World of Vision script. And this again is not my script completely. I have edited it to fit the bill better, but I have linked to the GitHub repository. I pulled it from here. So it has a radius and angle where it can see. It has a reference to the player object. It has layer masks on what it is targeting and what it cannot see through. It checks if it can actually see the player. At game start, we basically just start the coroutine that checks, hey, can we actually see the player? And this is how we actually check the player position, if we can see it 5 times a second. So it has a collider for array of colliders, because we are all the different layer masks or colliders that have the layer targeted mask, so the target layer on them. And if the strength length check is not 0, we see the player. And this is just a lot of math on what direction the player is in and all that. Checking that we for certain can see the player. And we make a raycast if we can make a raycast to it. So if we cannot make a raycast, then we cannot see the player. Yeah, that is basically the AI explained in a sense. It just checks if it can see the player. If it can't see the player, it picks a random position to go. If it can see the player, it goes to where the player is. Rest of the game is basically... This is the dirty fix. I haven't said it here. I don't like this fix, but whenever the player position gets to -9 or below, it changes its position back to 9, so it's always on the level. It can be a bit buggy, but oh well. This is not about the game. Level tilt manager is basically just checking, hey, do we change the level tilt so the player can move around with the rolling motion. That we can actually remove. There's no use. This is done with the new AI. New unit is thing. I was also supposed to add origin rotation, so I never got around to it, but it's not actually. Just add it here. On update if input dot get button key down and key code space. Quaternium dot Euler and 0 0 0. That should do it. We're not gonna need that in anyway. And this is also from an old system where I tried to transform it dynamically as you press the buttons, but that turned out to be not good for the NavMesh agents. They don't really like ever-changing angles on their surface they are moving around. Oh. Technically now, if I saved it. Did I save it? Yes. That should now always be able to rotate it back on, yeah. Yeah. And that is basically how the AI works. In the first part, or explaining the first part, and the field of view, we can also take this. This is not my code either, but this is a editor code that just draws the gizmos on the screen. Again, not my code. Not my code, I still need to comment this out so it is readable for everybody else as well, and I need to figure out how it works exactly as well, because from what I understand right now, it just takes yeah, I have written this once before, and now I just copied it without comments. Because it doesn't have any comments, I have actually no idea how it works exactly. Anyway, that's not the point of this because it's just a visualization for it. This is the point of it. So yeah, do we see player? No. Pick a random position. We see player, go to player position. If player position is less than 5 and the actual player position is less than 5, either or, return success, reset the game. Well, it's not implemented yet, so it just keeps going to a different location. And then we reset the path, so the loop can start again. And let's see with the fixes, does that also fix the issue where it got stuck? Yes, it fixed the issue where it got stuck as well. Good. Yeah, that is the AI. Kinda sad I never got around to building my own version of the behavior tree. I probably will try do it again. Doing it again with better time. But for now, this is what I got. I hope it's good. You can find all the code, everything else from GitHub page for the project. I have that also linked in the description for the video. And